schön, Sie persönlich kennenzulernen, Herr Professor
Nice
Butz.
to get to know you personally, Professor Butz. It would be best if you could introduce yourself.
Mein Name haben Sie gesagt, Andreas Butz.
Well, you just mentioned my name, Andreas Butz. I am an IT expert by training. I studied that.
Im Endeffekt für eine Universität.
And then finally decided to go into a university career. I'm now at the university in Munich and I'm teaching in the Department for Information Technology, and in the area of media informatics I am working in the field of human-machine interactions and graphics. Sounds like just the bare bones of your job description, but if we were to round this off, you are a professor for media informatics at one of the excellent universities of Germany, and you are the head of the department for human-machine interactions, both in research and in teaching, and you're a member of the scientific board for the German Research Center for Artificial Intelligence, and in 2007 you received the Research Award for Technical Communication for your research work in the field of human-centered intelligent environments. What's your explanation for your success?
Mit Begeisterung für
Well, I think it's the passion for the subject.
immer meine Richtschnur.
You know, that was always my guiding principle, to actually only do things that I'm interested in, that I feel passionate about. And it also leads to a somewhat less than regular CV, if you will. I actually, when studying information technologies, asked myself whether I just wanted to work with machines for the rest of my life. And back then I thought about becoming a teacher. Back then there were no teacher studies for the field of informatics, just mathematics and probably a foreign language would have been my choice. And then I went to get information about these different university careers, and I found out that I would have had to work twice as hard as for the informatics studies that I had already taken up. So I decided to just finish those and then decide afterwards. And then when I was preparing my diploma, a subject popped up that was rather more concretely focused on human beings, and I stuck to that. Then got a doctoral fellowship, and I thought, okay, then I'll try and get my PhD. And then as a postdoc, I then studied at the Columbia University in New York, working there also for a year, and I developed user concepts for augmented reality environments. Augmented reality is probably something that people are more familiar with because of their mobile phones and the things that you can do with them, but the original idea was to actually get engulfed in a complete virtual reality that is overlapping reality, which means as a human being I'm still in my physical environment, but I can see digital things in this environment. Technologically speaking, the solution that you use is a head-mounted display, which is something like a pair of goggles that you're looking through, and then I could, for example, see an icon here on the table that I could then click onto, and a media object could be linked to that. And those were the things that I used to work in back then, and that actually led me to thinking about the fact that we are living in an increasingly digitized world, and that digital information is very important in many different areas, also in real life. I mean, we cannot longer clearly separate real life, you know, and digital life. There is no distinction between those areas, and to actually mix these areas up was very fascinating to me, and this really made me feel very passionate again about going into a university career. And then in my CV there is another, you know, path that I took when we founded a company in order to establish some of the inventions that we did based on our research, and I was an executive director there in that company for 2 years, but I found out that others are better at marketing and commercializing these ideas, and went back to the point where these ideas are being born, and that is at university. And then I just, you know, followed my basic question of what happens when we mix up the digital and the real physical world. And then I tried to actually implement this here at the MU to the Munich University again, but following new approaches. I thought that we should not have to make people wear these head-mounted devices, or we should not make them put on gloves or use other forms of complex technological devices, but that people should rather be able to use the digital world in their real-world environment without any kind of auxiliary devices, but just by using their hands. And that is how I ended up with the subject I'm currently working on, interactive surfaces, interaction with gestures or in different contexts. We're working on the subject of interaction with digital technology in your car, and of course attention, in where people direct their attention to, is a very interesting subject. And then I became a teacher here at the university, so I did not embark on that road while studying, but in my career I actually ended up as a teacher too, and I'm working with people, which is at least as important to me as working with machines. So if we were to talk a bit about man-machine interactions and the concepts for a little longer, could you perhaps define this a little more clearly? Well, I can make an historical excursion if you want. If we look at computers and how they developed, then in the beginning there were complex technological devices that were constructed by someone, and that someone was also the person doing the programming, which means the developers of the computer system was also the programmer and the user. And then they used those machines to do, for example, complex physical calculations. And then in the 80s, approximately, people started talking about personal computers, and they started selling computers that had one particular user, and then the user was someone else, someone entirely different from the person who built that machine. But what did not really develop alongside this is that if you actually construct a device, if you build a device that many people are supposed to use without having the necessary technological background, then you have to construct it in a way that people without this special expertise can actually use them. And this is only a partial success. There were graphical user interfaces, and people tried to set up office environments with documents and files on the desktop of the computer, and they tried to emulate this office environment, but still there was a large demand for technological understanding. You needed to know what the individual parts of the computers are for. You have hard drives, and you've got icons that symbolize the hard drive on your computer desktop, and so for that people need to have a certain amount of background knowledge concerning the technology. And I think this is basically the wrong approach. If today, for example, we were to write something onto a piece of paper with a pen, we do not think about the chemical characteristics of the ink. But if we use a computer in order to work on a text or compose an image, then we know we need to have some technological background that is not relevant to writing the text. You know, a writer should not have to know how many megabyte storage capacities will be necessary for specific processes of your computer. These are two different things, and that is what really drives me in my research, you know, to get away from that and to actually be able to start building systems that we can operate without a technological background knowledge. And now that we are getting out of the era of the personal computer, we are now entering into the era of mobile phones and tablets that are really ubiquitous. Personal computers still have, you know, their right to existence. I mean, to have a keyboard, for example, that is just the best possibility for writing a text. The tablet is the wrong tool for that. But, you know, informational tasks in your everyday work, for example, or how to deal with our media collection, the photos that we have, the music that we have, we can do that on tablets and mobile phones nowadays. There is a well-known scientist who's also founded the area of ubiquitous computing, Mark Weiser, and he's a scientist who once formulated a vision as to how computing could look like in the 21st century. He developed some scenarios, and in one of his scenarios, intelligent devices are important. For example, a pen that you can use in order to mark piece of text in a newspaper and that you can then send on as a message to another user. And in order to do that, I don't need to know anything about the network connections of this pen into my technological environment. But these are the technological kinds of problems that people still feel are obstacles when it comes to using these technologies. I would even go so far as to say that there is a social responsibility to make computing available and accessible to people without technological background. Computing technologies should be accessible to all strata of society without requiring them to have technological background knowledge. Now the question is, how far would you like to go? Is the intention really to have human beings being able to focus more on the creative side of things, or is it about, being able to just sit on your sofa and watch television lazily? Of course, watching television is part of the everyday life of many people, but I think that, human beings should actually devote their time to what they want to do. Be it writing a text, painting a picture, compose a piece of music, they should not have to deal with the tool they are using. The tool in this case is the computer, and that should be so far in the background that people no longer perceive it as a tool. When a composer sits down at a piano, then he's not thinking about, the physics of the sound creation and the different parts of his piano, but he's rather just using the instrument. And a writer, well, I don't know, I guess that, with that typewriter or with his pen, he will, feel as one to a degree that he no longer has to think about the tool he's using. And I think this is one of the fallacies of the computer technologies that we're using today, that we have to think too much about it as a tool, that we are really defining processes along the lines of what the tool can offer us and not along the idea of what we want to do. Well, that is really interesting, especially for people like me, for example, who did not grow up in times of these technologies, when so many things had to be learned, in a cognitive fashion and not in an automated fashion, if you will. It would be great for people like me, of course, but what do you think about the new generations that actually were born into this age and era of these technologies and who just acquire these skills and this knowledge and then start teaching their own teachers about these things? So do you want to take a step back, or do you just want to further develop things? Well, I would like to make a distinction here based on functional principles that we can generalize and that are of a lasting nature, and then we also have to look at rather more specific things that may look entirely different in 2 years' time. Let's take examples for both cases. As children, we learn to deal with our physical surroundings, with the environment. We learn about how objects behave in the world if they have a certain amount of mass and inertia. We know how it moves after giving it a push. And if, for example, in a user interface we find specific phenomena, this is the case with many mobile phone operating systems, that you've got user interfaces that behave physically, that you've got, I don't know, balls or ribbons that you can move and that, move to and fro, that have their own speed when I give them a push. These are examples of operation concepts that are based on the real world and are thus intuitive and can be easily used. If we were to limit ourselves to that, that would be probably a limitation that would be too strict. But we can, of course, expand these concepts. If you make this kind of movement, this kind of gesture with your fingers, everyone knows what you mean. This is a gesture for scaling graphics on a screen. And this, of course, goes beyond the normal physical behavior of material in the world. You wouldn't really do that on a piece of paper in order to increase the size of a picture. The physical material in the world just wouldn't work like that. But Apple put this into a TV ad And people liked the TV ad, and at the same time learned, subconsciously that they can enlarge images on screens like that, or push tables across the screen, and this is now part of the general knowledge. I watched young people who in the underground in Munich went to a rather old-fashioned terminal and did not use the keyboard but tried to use this gesture on the screen. So this is now part of the repertoire for us as to how we deal with the digital world. Now this is a positive example. These kinds of expansions of the physical world will be more and more present, and we will learn more and more about them, and we will grow up with these things, and it will become quite natural to use these sorts of gestures. And on the other hand, we've got, the knowledge that is rather more in flux, where in which menu, for example, you have to key in the key for your wireless LAN in a specific computer program. This will change until the next generation works with this technology, and it cannot be scaled up or down to other cases of applications, and we should try and get away from that. We should try to hide this part of the technology as well as possible from the users, so that they can just fulfill their tasks. You're working in healthcare, music, cooking, phone displays, many different areas, so it is really a large variety of different subjects. If you just look at the titles of the publications on your website, it's impressive. And how do you do that? How can you work in such an interdisciplinary fashion, cross-sectoral fashion? Well, we work together with many students who are just as passionate about the subjects they choose. I mean, this is part of what I really enjoy most working at the university, that you always are surrounded by young people with fresh ideas. As a university teacher or as a professor, apart from, of course, the burdensome administration work, what really is the biggest fun is to work with the doctoral students to develop ideas and concepts. And I've got different PhD students who are interested in different fields and areas, and then of course this is infectious, you just go along with their ideas. You mentioned the kitchen, that was one of my PhD students, then music. Well, that was one of my students who looked at environments and instruments, and she just developed interactive environments. And this young lady, she also likes cooking, for example, and she proposed to just develop a system that could support people when cooking meals. And she said that she'd like to have a system that is able to bridge both space and time between myself and people that I really adore, like my grandmother, who's got such a pasta recipe as not to be found anywhere else in the world, and she could cook that meal in her kitchen in Italy, for example. We could bridge that gap in time and space, and I could then cook it either the very same day or a week later. And then we set up such a system in the kitchen here in our department, and it worked out. And music, well, is one of my hobbies, and I had a PhD student who was also a very talented musician, and we asked ourselves, what could be done in, areas or in soundscapes, like, for example, in a grocery store. What can I do with the acoustic environments? This is a very good example, the church bell ringing, that, on the one hand tells me the time, and on the other hand is audible in the background. And we thought about how, these kinds of messages could be integrated into the music, for example, in a grocery store. Specific messages for individual people, and she composed different pieces of music that are set up out of different components that you can add or omit, and we then had people choose their favorite instrument in a study that we carried out, and then this background music was played at a volume that was not really yet, consciously audible, like in a grocery store, for example, or a department store, and it creates a good basic mood. But whenever we get to hear one of our favorite songs, then it actually enters into our consciousness, because it is a signal that triggers our attention to be focused on that, and we did that during our study. we, then played back either the favorite motive or the favorite instrument to these people while the music was ongoing, and then people showed a heightened state of attention. And, this was a kind of way of transporting a message to these people, to these particular people, because others would not have really grasped that fact that there was a change, and this is a concept that we try out between the digital world and the real world. You just mentioned cooking, you mentioned music, healthcare, phone displays. Well, phone displays. Here, of course, when we're working on the technological basics anyway, that go into smartphones, then, of course, the question as to how we can do more than just, pressing onto icons and use it as a phone. What we could use these devices for, on top of that, is quite natural, really. And we actually designed something that does the following. I mean, just imagine, we've got a smartphone with a camera on the back of the phone, and I've got that camera. If I switch that on and look onto the screen, well, then it's like looking through the phone, for example. And if I look onto a screen through my phone, then I can even make specific choices or pick things on my phone screen. If there is a poster on the wall, for example, then I can choose specific functionalities here on my phone. Or I can copy elements of the poster and then put it onto my tablet PC and just drop it there. And suddenly, the smartphone becomes an instrument for making physical interactions in the real world. So I can use parts of the digital world and move them around in the real world, use them, operate on them, and I again have a direct integration between the physical and the digital world. Well, you could also combine that with cooking, If you see a pizza in a video, for example, then you could start a 3D printer, for example. Yeah, well, I wouldn't eat what comes out of that, at least not currently. But, I mean, you probably have a lot of fun, with your students. Yes, and that is actually why I'm so enthusiastic about my job. It's really a lot of fun to think about these new ideas, and not just to do it in your head, but also to be able to at least partially implement them. And then use one of those prototypes and, go to people, have them try it out, watch them how they deal with this new form of technology, whether people can understand it, and you actually get to find out quite frequently that you may have come up with a stupid idea and that you got hung up on that idea if things don't really work the way you imagined them to work, and in other cases you actually stumble across interesting effects that you wouldn't have thought of yourself. And you get to have an influence on people's lives that you would never have anticipated, Years ago, I had a rather surprising success when I then ended up on the front page of the Bild newspaper in Germany with one of my researchers. That was shortly after I moved to Munich. And one morning, I went to the office, and a number of TV and radio stations had already called wanting to interview me, and I did not really know what this was all about. And then, turns out that the whole thing was based on the following story. During a study project at the University of Saarbrücken, we had developed tangible user interfaces. That means that we've got physical objects that are linked up to the digital world. And one of these objects was an interactive beer mat. And it had a weight sensor and a gravity sensor, and unfortunately I don't have anything here right now. Now imagine this is my beer glass. Now I could put it onto the beer mat, and the sensor could tell whether the glass was full or empty or half empty. Yes, and of course the simplest possible use is, that if you lift off the glass and you shake the beer mat, that you could order a new beer with that. Then you could think of other things. And we actually sat down together and just did a couple of rounds of brainstorming, writing down the ideas that sounded most plausible. Another possible use was that you are, for example, in a karaoke bar, and you lift your glass to toast the person who's singing there. This would be a positive vote, you know. You actually like what he's doing up there on stage. Or you lift your glass and turn around the beer mat, and that would be a negative vote. And like that, for example, I could use these beer mats for a voting system in a karaoke bar. So we wrote down a couple of these ideas. We were then accepted to an international conference, presented that at the international conference, and it was published. And then a British newspaper found out about that during that conference. It was the New Scientist. And they actually wrote an article about the invention, and they also formulated a press statement, which was then distributed via DPA. And that was only a couple of weeks before the Oktoberfest. And of course, if there is a press statement only a couple of weeks before the Oktoberfest stating that German scientists have developed a beer mat that can automatically order your next beer, then of course this calls journalists to action. Within just a single week, I had 2 TV teams here, and we, you know, then reenacted the scene in a neighboring pub, and of course we had a fully functional prototype of that beer mat, and I ended up on the front page of the Bild newspaper. And then we got, you know, absolutely unexpected feedbacks. An owner of a karaoke bar in Holland, for example, wrote me an email and said, now this would be really research that does not, you know, respect people's endeavors, you know, in that in a karaoke bar you are not trying to vote people off the stage, but that everyone's just trying to have fun. And of course we did not really think that deeply about the issue at hand, but the fact that I got this kind of feedback, you know, speaks for itself. I got emails from children who then made school projects based on our interactive beer mat. And, you know, whenever technology becomes palpable in your everyday life, if you've got examples from your everyday life, then it becomes also understandable for people. And sometimes it triggers rather unexpected reactions. And that's very interesting. You know, working at the university and working in research, you have the opportunity and you also have the responsibility of thinking about the future of how we deal with technology and help to shape this kind of behavior. And of course, you know, the things that we develop today, there is, you know, a certain chance, and every once in a while you are more successful, there is a certain chance that some of these ideas may end up as parts of products. And there are parts of our research that are just basic research, others are more user-oriented. Here in Munich, we stand quite good chances to work and cooperate closely with the industries, especially when it comes to the automotive industries. We've got very close cooperation, and we've got a number of PhD students who are working in that field, and there we, you know, regularly submit several patents per year, and it is very likely that some of these ideas will one day end up as a part of our new automobiles, our new cars. This is where we're closer to the technology with our concepts. Now, there is one question I actually wanted to ask you, you know, the effect of playfulness, you know, something must have, you know, left his or her mark on you. What is it that allows you to have, you know, maintained this playful approach? Is it something from your childhood? I think it really is palpable, you know, because it's also important to know, you know, when you start being a scientist, you know, even as a child is possible, right? Well, I was a curious child, and I was always, you know, I always got the support of my parents for that. When I was a child, I used to disassemble my toys. Sometimes my parents were really astounded about that, but basically they did not try to stop me, you know. I actually accepted the fact that sometimes afterwards the toy may be broken, but I just wanted to understand how they worked. And, you know, it worked better and better, and I was later able to repair these toys. And I once went to visit my school class friend, and he had a remote-controlled car, and his mother was not used to my way of playing, and we actually disassembled the whole car, and she was shocked, but then we actually assembled it back again, and everything was good. And of course, curiosity is the most important aspect. Yes, curiosity is one of the primary aspect of intelligence. Yes, and I try to pass this on to my children, to never try and stop them in their curiosity, but to rather support them. Even if they ask me why, 20 times in a row, I always try to find an answer to their questions that makes sense. And if that's not possible, we try to find out together by just trying out things. We're doing experiments together, for example. We go onto the Karwendel mountain top and we carry a bag of chips with us and see whether the bag would pop because of the pressure differences. Julian Niederrümelin, in his presentation about ethics and IT 3 days ago, said that with every new technology there are those who are euphoric about it and those who are alarmed about these new developments. And that is a constant element in the history of mankind. What kind of person are you? Well, I try to stay somewhere in between and strike a balance. I don't know whether I'm always successful in doing that. Of course, to be euphoric about a new technology is quite frequently rather too uncritical and not really helpful. To be against things, on a rather general basis is also problematic. I try to use my available background knowledge in order to assess new technologies, to come up with my own idea as to what it could mean for me, personally, or for mankind, and then judge accordingly. So I try to stay in the middle. There are so many interesting things that we heard from you. Could you now perhaps tell me, of all the things that you just mentioned, what is the most important thing for you? What would you like to pass on to the young people, the future information technology engineers? Well, to the young talents in IT, I'd like to tell them that they have a responsibility. They have a responsibility to make computer technologies usable and accessible to everyone. Computer technology nowadays is just of such a basic importance like electricity or, writing was for former generations. Computer technology that is just accessible to a case of tech-savvy users is dangerous. Computers should be usable by everyone. That is very important. That's my message to the young IT talents. And as a last question, as you are also dealing with questions of automation and artificial intelligence, perhaps you are closer to the subject. Perhaps you could tell us what is the most important thing in real life at the end of the day. Well, to stay in contact with other people. Yes, to actually stay in contact with other people, be it your family, be it my colleagues when teaching at university, in school, in associations, in sports clubs. That, to me, is the most important thing in life. And technology can support you there, and then it's good. It's good if it does. But it should never stop you from having real contacts. Well, with that, I would like to thank you. Thank you for your time.